Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 8, looking at lessons 6 and 7, solving systems with substitution. And so we've started to talk about these systems in this unit. And so we have a few vocabulary terms here. A system of equations basically is going to be two or more equations that share variables. So we're looking at, in our case, we're going to be looking at two equations that have the same variables and looking for a solution that makes both of them true. And then the method that we're going to be using in this one is called substitution. And you have a definition there. So we're going to solve one of our equations for one of the variables. So usually we're dealing with x and y. I'm going to solve one of those equations for x or solve one of those equations for y. And then I'm going to use that to plug it into the other equation so that I can solve it. And so I think the best way to look at this is through some examples. So we have two that we're going to look at here today. So I have a system of equations, negative 7x plus y equals 4, 3x minus 2y equals 3. We want to solve this system of equations using substitution. Now, we could always use graphing like we had done previously. I can graph these two equations and I can look for the point where they intersect. Definitely can always do that. Substitution is a method that I can just use algebra to find what that point of intersection is. So we want to look at that as well. And so here in our first one, we want to get one of these equations solved for either x or for y. And if you notice in this first equation, it would be pretty easy to get this one solved for y. I would just need to move that x term over to the other side. So I would add 7x to each side. So if I have my equation, negative 7x plus y equals 4, if I add 7x to each side, then that zeroes out over here and just leaves y. Here I would have my 7x plus 4. And so now I know that y equals 7x plus 4. And so what I can do is I can take that second equation, the 3x minus 2y equals 3, and I'm going to plug that 7x plus 4 into this in place of y. So instead of 2 times y, I'm going to take 2 times that 7x plus 4 because I know that 7x plus 4 is equal to y. And then finishing that equation equals 3. And the reason we do that is now I just have one variable. I have x. I have a few different places where I see x, but now the y is gone. And so I can just solve this equation for x. So I'm going to start by distributing that negative 2 to each term here. So I'd have 3x, negative 2 times 7x is negative 14x. Negative 2 times 4 is negative 8. Now I can combine my like terms. 3x minus 14x would give me negative 11x. Minus 8 equals 3. Then I would add 8 to each side, which gives me negative 11x equals 11. And then finally, divide each side by that negative 11, and I get that x equals negative 1. All right, and so my solution to my system is going to have an x value of negative 1. I also want to find what the y value is. And so to find that, I'm going to plug that negative 1 back into one of these equations for x. And I'm just going to choose the first one. I could use either one. I'm going to plug in negative 1 for x plus y equals 4. Well, negative 7 times negative 1 is positive 7. So 7 plus y equals 4. And then finally, I would subtract 7 from each side. And I get that y equals negative 3. And so we would say the solution to that system is the point negative 1, negative 3. So if I graphed those two equations, those lines should intersect at that point negative 1, negative 3. Excuse me. All right, let's do that one more time here. Next set of system of equations we want to solve using substitution. And again, substitution is best when I have a variable that's easy to get by itself. And so here in that first equation, I can isolate y pretty easily here. I'm going to start by adding the y to each side so that it gives me a positive y on this side. And then I can add 8 to each side to get that y by itself. So I get that y is equal to 4x plus 8. So I know that y is equal to 4x plus 8. I can use that in that second equation. So I have negative 5x plus 3y. And in place of the y, I'm going to use that 4x plus 8. That equals 10. Then I'm going to distribute. So 3 times 4x is 12x. 3 times 8 is a positive 24. Combining like terms, negative 5x plus 12x is positive 7x plus 24 equals 10. I want to get that x term by itself, so I'm going to subtract the 24 from each side. That leaves me with 7x here. 10 minus 24 is negative 14. And then finally, to get that x by itself, I'm going to divide each side by 7. And I get that x equals negative 2. So again, that's the x value in my solution point. To find the y value, I'm going to plug that negative 2 in for x into one of those equations. I'm just going to go ahead and use that first equation again. So 4 times x, so 4 times negative 2, minus y equals negative 8. 4 times negative 2 is negative 8, minus the y equals negative 8. I can add the 8 to each side. And I get that negative y equals 0. Divide each side by negative 1. It's not going to change that value for 0. So our y value for that solution point would be 0. So negative 2, 0 would be our solution for that system. All right, and that's all I've got for you today on solving systems with substitution. As always, if you do have questions, please let us know. Thanks. Have a great day.